The use of outer space or celestial bodies other than Earth for long-term residence or as alien territory is known as space colonization, also known as space settlement or extraterrestrial colonization. Building space towns or extraterrestrial mining operations, for example, has been suggested as a means of achieving the habitation and territorial usage of extraterrestrial space. No extraterrestrial territory or land has been formally claimed, nor have there been any permanent space settlements other than temporary space shelters. International space law, recognizing space as a shared heritage, forbids making territorial claims in space. In order to prevent colonial claims and the militarization of space, international space law has pushed for the establishment of international regimes to control access to and sharing of space, especially for specialized places like the Moon or the constrained space of geostationary orbit. There have been many justifications offered for and against space colonization. The survival of human civilization and life from Earth in the event of a planetary-scale disaster, whether caused by nature or by human activity, and the presence of additional resources in space that could enable the expansion of human society are the two most frequently cited arguments in favor of colonization. Concerns that the commodification of the cosmos may serve to further the interests of the already powerful, including major economic and military institutions, as well as the enormous opportunity cost compared to using the same resources here on Earth, as well as the exacerbation of already harmful processes like wars, economic inequality, and environmental degradation, are among the most frequently voiced objections to colonization. The precedent that a space settlement would create will bring up many socio-political issues. Even just building the necessary infrastructure comes with a sizable number of technological and financial difficulties. Space settlements are typically envisioned as material and organizational structures that must meet almost all, or all, of the demands of greater populations of humans in a hostile environment that is unavailable to maintenance and supply from Earth. It would require the use of technology that haven't been significantly developed yet, including controlled ecological life support systems. It would also need to address the as-of-yet unresolved problem of how people will act and survive over the long run in such environments. A space settlement would currently be a wildly costly endeavor due to the current cost of putting anything from the surface of the Earth into orbit, about $1,400 per kilogram or $640 per pound, to low Earth orbit via Falcon Heavy. On the technological front, advancements are being made in automated manufacturing and building methods, as well as cheaper access to space. Reusable launch systems could cost $20 per kg to orbit. There are currently no large-scale plans for creating a space settlement by either a government or a private company. Nevertheless, there have been several suggestions, theories, and plans for space settlements over the years, and there are numerous organizations and advocacy groups that support space colonization. Many well-known scientists have expressed support for space settlement, including Freeman Dyson. Along with the term settlement, which is loosely applied to any human space habitat, from research stations to self-sustaining communities in space, the phrase has been used extremely liberally to refer to any permanent human presence, even robotic. The terms colony and colonization have their origins in Earth's colonial past, making them both human geographic terms and, more specifically, political ones. This wide application to any ongoing human progress and activity in space has drawn criticism, particularly for being imperialist and undifferentiated. A colony in this sense is a settlement that appropriates land and uses it for the benefit of the settlers or its metropole. Consequently, a human outpost does not inherently qualify as a space colony, even though it may be a space habitat or even a settlement. Although trading factories and other entrepôts frequently expanded into colonies. Disputes about location are common among proponents of space colonization. A physical body planet, dwarf planet, natural satellite, asteroid, or an object in orbit can all be potential sites for colonization. See also space habitat for communities that are not on a body. Due to its proximity to Earth and slower escape velocity, the Moon is being considered as a possible location for colonization. However, because the Moon lacks an atmosphere, it offers no protection from space radiation or meteoroids, hence lunar lava tubes have been suggested as sites to receive protection. Abundant ice in some areas might supply the water needs of a lunar colony. Concerns about the Moon's low surface gravity include the question of whether 1/6 gram is adequate to sustain human health over an extended period of time. In the 21st century, there has been a rise in interest in building a moon base as a stepping stone to Mars colonization, with ideas like the Moon Village for permanent settlement and facilities for research, mining, and trade. The stable Earth-Moon Lagrange points L4 and L5, where a space colony can float eternally, are another near-Earth possibility. In order to encourage colonization, the L5 Society established space stations at these locations. As a result of the shallow effective potential at this location, Gerard K. O'Neill proposed in 1974 that the L5 point, in particular, could accommodate thousands of floating colonies and make transport to and from them simple. Mercury is now recognized to be volatile-rich, unexpectedly richer in volatiles than any other terrestrial body in the inner solar system. Mercury was once assumed to be a volatile depleted body like our Moon. Solar energy is a tremendously efficient energy source that might be harvested using orbiting solar arrays and broadcast to the surface or exported to other planets because the planet receives 6.5 times as much solar flux as the Earth/Moon system. This may make Mercury the perfect spot to develop and launch solar sail spacecraft, which might launch as folded-up chunks by mass driver from Mercury's surface, according to geologist Stephen Gillett in 1996. The solar sails would be deployed once in orbit. Solar sails near Mercury would have 6.5 times the thrust they do on Earth, and solar energy for the mass driver should be simple to obtain. As a result, Mercury might be the best spot to find resources for constructing gear to transfer to and terraform Venus. Large solar collectors could also be constructed on Mercury or in its vicinity to generate energy for massive engineering projects like laser-pushed light sails to nearby star systems. The average surface temperature on Venus is 464 degrees Celsius, which is hot enough to melt lead, and the average surface pressure is 92 times that of Earth's atmosphere, which is about equivalent to a depth of 1 kilometer beneath Earth's oceans. There is some variance. Because of its altitude, the summit of Maxwell Montes is the coolest and least pressurized spot on Venus' surface, with temperatures and pressures of only 380 degrees Celsius and 45 bar, respectively. Additionally, there are few hotspots of roughly 700 degrees Celsius. Because of the ongoing cloud cover and the toxic nature of the carbon dioxide atmosphere, solar energy is not accessible at the surface. Although there is a lot of material in the asteroid belt generally, it is thinly scattered since it occupies such a large area of space. Ceres, the largest asteroid, has a diameter of 940 kilometers, making it large enough to qualify as a dwarf planet. Pallas and Vesta, both with diameters of around 520 kilometers, are the next two biggest planets. Unmanned supply craft ought to be feasible with current technology, even while traveling 500 million kilometers via space. The colonists would be very interested in preventing their asteroid from colliding with Earth or any other large body, but they would have a very tough time moving an asteroid of any size. The majority of asteroids have considerable momentum, and their orbits are very far from the Earth's in terms of delta V. Perhaps asteroids could have rockets or mass drives attached to change their route into a safe one. Water, ammonia, and methane are abundant on Ceres and are crucial for terraforming Mars and Venus as well as for ensuring human survival. The colony can be built underground or on a crater on the surface. However, even Ceres can only muster a meager 0.03 g of surface gravity, which is insufficient to counteract the harmful consequences of microgravity, though it does make transportation to and from Ceres easier. Thus, it would be necessary to use artificial gravity or medicinal therapies. Additionally, it would probably be necessary for infrastructure to already exist on the Moon and Mars for the main asteroid belt to be habitable. The principal international convention, the Outer Space Treaty, serves as the legal framework for space activity. However, the legal area of space law has grown to encompass many international treaties, such as the Moon Treaty, which has received far less ratification, as well as numerous national laws. The fundamental guidelines for space activity are outlined in Article 1 of the Outer Space Treaty, the exploration and use of outer space, including the Moon and other celestial bodies, shall be carried out for the benefit and in the interests of all countries, irrespective of their degree of economic or scientific development, and shall be the province of all mankind. Outer space, including the Moon and other celestial bodies, is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means, the declaration continued in Article 2. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.